higher tier mock exam in February 2026. Let's get on with it. Right, I'll talk through a little bit about what these things mean, as well as give you the examples and see where we get to. Right, number skills. There's the things within number skills: evaluating powers, ordering fractions, decimal percentages, using given calculations and reciprocals, and then a few examples of these kind of things. So starting off with the powers stuff, okay? An understanding, I guess, that you know that little 5 means to multiply by itself 5 times, and you basically work that out. Then times 2, then times 2, then times, I don't know why I've gone for 5, and then times 2 again. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay. The cube there means what number times is by itself 3 times to make 125. So for example, is it 1 cubed? No, because 1 cubed is 1. And is it 2 cubed? No, with no of these as well. That's why I'm doing this. 3 cubed, 3 times 3 times 3, 27. 4 cubed, 64. And then 5 cubed. Well, 5 times 5 is 25. And 25 times 5 is 125. So the cube root of 125 equals 5. Worth knowing all your cube numbers up to 5 cubed, I'd say. Okay, there's a chance you'll get a cube root of one of those. Right, put in ascending order. I'd be looking to turn them all to percentages. So 37% can stay as it is. 2/5, I know the word percent means out of 100, right? So if ever I got to convert something, a fraction to a percent, how do I get that to 100? Well, you could go work out how many 5s go into 100 and go direct, or you could just times that by 2, is sort of a shortcut. So go 4 over 10, and then times those by 10, and you're up to 40 out of 100, which, and I keep writing equals, which equals 40%, so a little bit bigger than 37%, and then 0.3, which isn't 3%, but is 30%. Okay. On the line of making things into percentages, this is the same thing. What percentage? Change this to a percentage is, other way around. So they put is, not instead of is 24 out of 80, they've put of 80. What percentage of 80 is 24? In other words, 80 is the bottom number, and we want to know what is 24 out of 80 as a percentage. But again, we need that out of 100. Not as easy as going from 5, going from 80, because it's hard to get up to 100 from 80. So one way might be to go down to 10, to actually, instead of times, to divide down, to simplify it a little bit. So 8 goes into 24 3 times and into 80 10 times. Now though, notice the similarity with this, that we've worked to getting it out of 10, and then we've gone up to 100 to make 30%. So it's the same skill, right? These two things here, the same skill, just asked in different ways. Okay, given that 120, so, right, first of all, okay, look at the divide bit. The divide is this bit divided there by this bit with a few extra zeros. So let's go for a different color a minute, right, so we can see what's going on here. Scrolled up, don't panic about that. Sometimes does that. Okay, so I would start by writing out the sum in the order we wanted. So what they are asking for is, they are saying, look, let's go for 6, but don't write all the zeros yet. If I wrote 6,000 divided by 48, okay, then the answer would be 125. That's the point, okay? So 6,000 divided by 48. But what they've done is they put some extra zeros on both things. So now if I go back to red, let's work out how many extra zeros, right? So on this number here, there are 3 extra zeros. 1, 2, 3. And on the 48, there's 1 extra zero. Okay, if I cancel one of those with one of those, I can see that I'm left with 2 extra zeros. So my answer, rather than being 125, I need to add those 2 extra zeros. I'm not adding these 3 in blue here. I'm not adding these 3 because they were part of the original number that helped me to do the divide. 6,000 divided by 48 was 125. but it's just those extra ones. Once I've cancelled them, what have I got extra? They are the ones that are added on. And finally, in number work, the reciprocal of 4 is 1/4. Now, I don't think it does, but if it asks for that as a decimal, you might need to know that a quarter is 0.25 or a half is 0.5, you know, simple fraction to decimal conversions. We are on to angles, round 2. Some angle facts and some parallel line properties. So, not triangles, 3, sorry, in a quadrilateral. So basically, if I've got a 4-sided shape, 3 of the angles in there are 137. I'll try and put them roughly, so it doesn't matter where they are, just 137, let's call this one 57, 86, just making it up, and our job is what's the 4th one there, right? So our job is to add up the ones that we know. We haven't got a calculator, so we're going to need to be pretty neat with our workings out or adding up. 1420, carry 2, 3 add 5 is 8, add 8 is 16, add 2 is 18, carry 1, 280, and then take that away from 360. 360, because we know they all add up to 360 degrees. Take 280 away from 360 and we get 80 degrees, which is our answer. Here, the angles in a quadrilateral are 360, but angles in a triangle add up to 180. So to start with y, let's add up the 2 we know. 50, add 80, like we did in the last one. Always add up the ones you know to begin with. Sorry, I'm a bit sniffy, got a bit of a cold, so apologies for doing that. Okay, and then the missing one, y, which is the one inside the angle, we'll work that one out first, is 180, take away 130. Nice, easy one. I think most of you would have done that without calculator. That's 50. And then the second angle fact, with one of these, right, is we've done the quadrilateral, 360, that's an angle fact. We've done the 180 in a triangle, that's an angle fact. And the second one we're going to use here is that these two are on a straight line, where this one is 50, and I'm trying now to work out that one. And angles on a straight line add up to 180. Okay, so take the 50 away from 180, and actually we go back to 130 for x. So y equals 50 and x equals 130. That's enough basic angle knowledge for angle facts. And then the second sort of question on angles is parallel lines. And what we need to know, we've done this in class here, is we find our parallel lines, which are here and here, and then we look for lines in between them. So things like that. And we know that this group would be the same as this group. Or if we drew a second line like that, this group would be the same as this group. Okay, so let's work on groups. Let's take a look at the 77 here, first of all. Okay, first of all, if I take that away from 180, I get 103. So the first thing I can tell you is that that angle in that is 103 because they're on a straight line. Now, what this drawing is missing is this line doesn't continue, because if it did, there'd be another 77 in here and another 103 in here, and we'd get the full group. But they're only showing us the kind of top two in the group there. They haven't continued the line. However, the group is the same up here. So this would be 77. This would be 103. This would be 77. And this would be 103. Okay. In this one, we got 48 here, right? If I take that away from 180, I get 132 in here. But also then 48 and 132. Now, I may need them down here as well. 48, 132. I don't know, right? But actually, in this case, the one that they're asking us for, another colour again, is x up here. Now, this is not linked to any of the groups. This one is just part of this triangle here, okay? So for x, we're just using we're just using angles in a triangle. So we're going to add the 48 and the 77 that we know. 15, and then 11, and 1 is 12, so 125, and take that away from 180, borrowing from the 8 this time. 10 take away 5 is 5, 7 take away 2 is 5, and 1 take away nothing is 0. So that's 55 degrees, an angle at that. Really am sniffy, sorry guys, it's cold, can't eat cold. Right, this is it's too nasty. It's too nasty, right? It would probably rely on a calculator. So as long as you understand why I've done what I'm doing, don't worry too much about whether you could have done the mental maths or the written maths. As long as you understand the kind of concept, you'll be fine. The idea is we know the probabilities have to add up to 1. Or if we're doing percentages, they would add up to 100%. But in decimals or fractions, they've got to add up to 1. I already know that blue is 0.4, right? So the other two, if I take 0.4 away from 1, I get 0.6. So this one and this one need to add up to 0.6. Now, I imagine the question you might get, although again, I haven't looked at it, may just say, they're the same. Yellow and green are the same. So you just half 0.6 and put 0.3 in there, 0.3 in there, right? This is a little bit overkill because what they've done here is they've said, right, we're going to split this 0.6 between 2 A's in here and 3 A's in here. In other words, there are 5 A's in total, but those 5 A's need to add up to 0.6. So on a calculator, right, we would do that and we get 0.12. Right, so each A is 0.12. So 2 A's are 2 0.12s, which is 0.24, and 3 A's are 3 0.12s, which is, it's a little bit too tricky for me, right? However, you may have preferred to do your workings out as percentages and then convert them back. So if you'd thought of this as 40%, right, and thought of this here as 5A equals 60%, you may have preferred doing 60 divided by 5, which is 12, so that A is 12%, or as a decimal, then 0.12, right? So this is 24% or 0.24, and this is 36%. So don't be put off in this question. If you think, no, it's easier to work as percentages, and then I'll just put my answers as 0 point, that's fine, okay? Calculate the probability that the winning ticket is green or blue. So green is 0.36 and blue is 0.4, and we have to add them together, okay? When you're lining them up to add them together, make sure the 4 goes under the 3. You can always add a 0 on the end. So we get 0.76. If the video goes dead, I don't like the software I use. I tend to use Microsoft Stream, but you can only record things in 15 minutes and then I combine them together. So if it goes dead, I'll re-pick it up a few seconds later, okay? So there might be a bit of a jump in the video is what I'm trying to say, but we should get through this one, at least before we get to that jump, okay? Now, with a calculator, right, I would do this a different way. With a calculator, I'd actually go, I'd change that to a decimal. We were just talking about changing it, and I'd do that, right? Same with this one, I do that. Change your percentage to a decimal and just times it by the number you want to, okay? Without a calculator, I think we've got to go down the 10%, 1% route, okay? So to get 24%, split it into 10% and 1%. So 10% and then 4 1%, right? I need 4 of those times 4, okay, and 2 of those. So 10% of 240 is 24. And then 1% of 240 is 2.4, but I need 4 of them. Okay, so these two 10% add up to 48, and these two 1% add up to 16, carry 1, 9. Oh, pen has decided to go on a roll. They were 9.6. Add them together, 48. Add 9.6. Look where I put the 9 in the units column. You can put a 0.0 if you wanted to there, just to make sure you align things, put things in the right columns, use your place value ideas. 6, and then you put your point in, and then in the units, you've got 17 units, which is 7 units and 110. Carry the 10. 57.6, okay? With this one, right, 3/4, we're going to divide by the bottom. 13.2, divide by the bottom number. 4 doesn't go into 1, goes into 13, 4, 8, 12, 3 times remainder 1, and goes into 12 3 times again. So 3.3, okay? And then divide by the bottom and times by the top. Again, we could do that as an adding up sum, 3.3 add 3.3 add 3.3, but I'm pretty confident I'm not going to do a written method for that because I think you'd get that, okay? Try the same, chaps, with these two. Otherwise, I'm conscious this video is going to go on. I was talking about, hopefully it's a little bit more seamless than that. Right, earlier on, we learned about angles. We learned this fact earlier on as part of our angle facts. Do you know, this pen has started going. So we can see a four-sided shape here. So immediately, we're looking at the internal, the interior, as they sometimes call it, interior, probably better than internal, the interior angles of a quadrilateral, and the sum of those, sum meaning they add up to 360. So the four things I see here add up to 360, right? But what I see here is 6x plus 10, and then I'm going to add onto that this one, 145, take away 2x, and then I'm going to add onto that one this one here, and then I'm going to add onto that one this here. So all I've done is written the four things I see and put plus in between them. That, add that, add that, add that. But we know that they add up to, or they will equal 360. So what we've done now is we've done this. We've formed an equation. We've said we know that all these bits of algebra and numbers add up to or equal 360. Okay. Next job then is to solve this equation. What is x? Now, at this point, we tend to move the numbers over that side of the magic bridge, as we call it. But before we do, I think it'll be useful here to simplify what we've got. We've got two families here, okay? What we've got, first of all, is we've got the X family, and there are 6 members of my X family. Here, I'm taking away 2 of them, so I'm down to 4. Then I'm adding, notice the sign before it, I'm including, adding 3, and then I'm adding 4. So how many have I got? I started with 6. I took away 2. I'm down to 4. I added 3. I'm up to 7. I added 4. I'm up to 11 members of that family. The other family I've got are just the number family. Yeah. So different colour for the number family, obviously. Okay. And I've started with 10 in my number family, and I've added on 100. Where did I get 145 from? Oh yeah, I can see 145 is in this one here. Okay, and then the last thing in the number family is this. And notice nothing is not in a circle now. So every sign with the number. So the sign before it goes with the number. So 10 add 145 is 155. Take away 15 is 140, is it? No. Sorry, 10 add 145 is 155. Take away 15 is 140. Yeah, sorry, it's just having a bit of a moment there. Right. So I've simplified. Equals 360. Now I can use my magic bridge. Now I can go, do you know the number family? We tend to take the number family over with the numbers on the right-hand side of the bridge. So we're left with 11x this side and 360. We need to take that 140 off. Okay, so 11x is 220. And to find x, we need to divide that by 11. Now we could use a bus stop, okay, but if we ignore that 0 there, if we ignore that for a minute, what I can actually see here is 22 divided by 11. 22 divided by 11 is 2. And then we can just put that 0 back on. And you'd get the same doing it there, okay? 11 doesn't go into 2, goes into 22 twice, goes into 0 times. Right. We now know that x is 20. Now, I don't know if it'll ask you for this. It does. It says calculate the size of each angle. Well, now that x is 20, this angle here is 3 lots of x, or 3 times 20. This is 4 lots of x, take away 15, work that out. This is 6 lots of x plus 10, work that out. And this is 145, take away 2 lots of x, and work that out so you can work out your angles that way. Okay, inequalities, integer solutions. Yeah, we did a lot of this, didn't we? Okay. It's about working backwards here, right? It's thinking of the inequality as a magic bridge, even though this inequality means less than, this side is less than this side here, okay? So the first thing here that I can see this loose of here is the minus 2. So 3x over 7 is less than, there's 3 on this side, but if I move that over and add it on to that side, my new answer is 5. The next thing I would move is the divide by 7. All right, that's not there now, it's over here, but the opposite of dividing by 7 is timesing by 7, which is 35. And the last thing I'd say, look, if 3 lots of x, if 3 times x is less than 35, then x is less than 35. The opposite of times it by 3, divided by 3. And that's good enough for solve. That's good enough. That's done. Right? Job done. Job done. Now, we got to work out what that is. 35 divided by 3 is, I'm doing this, it's hard to do this because I'm on screen, right? But I could write down the 3 times table. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. So 3 goes into 35 11 whole times, and then a remainder, an extra bit. So it's lower than 12, but more than 11 times. So 3 goes into 35 more than 11 times, but lower than 12 times. So the answer to this is more than 11, but it's below the 12. So it's in here somewhere, right? But we're told that x is less than that answer. X is lower than that answer. So x could be 11 or 10 or 9 or 8 or anything lower than 11. So what is the greatest value of x? Greatest integer whole number value of x? Well, that's 11. Okay? Prime factorization. We're doing well. Oh, I'm doing well anyway. Literally, prime factor trees. So something you got to just learn in maths, and you're going to have to learn it now for the summer, ready for the exam, is you need your first 5 or 6 prime numbers just to rattle them off. 2, 3, 5, 7, 11. But you could keep going, 13, 17, right, 19, etc., etc. But realistically, for a factor, prime factorization, you probably, oops, don't know what that was. How do I undo that? Now I've gone all the way back to the top. I'm not starting again. I'm just going to zoom down. So realistically, listening while I'm scrolling through, the ones you're going to use are 2, 3, 5, 7, maybe 11, maybe unlikely, but maybe 11. So we're going to split these numbers up now. All right, it's got this arrow through it. Don't ignore. So we're going to start with the 420. We're going to go, right, we need to split this up into something times something. The most obvious number of these here, right, that goes into 420 is 2, because it's something I can half 420. I'm pretty sure I can half it. If you're not sure how to, you're going to need a little division. 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 0 no times, so 2 times 210. The reason I've used 2, it's a nice prime number, and I can circle it. Now I could go 2 again. I could, right? Because I can see it's an even number. 210 ends with a 0. Should divide by 2. 2 goes into 2 once. 2 doesn't go into 1, carry that one. And 2 goes into 10 5 times. So this time we've got 2 again, but 105. Can't use 2 anymore. Can't use 2 anymore. Not an even number, not a number. But because it ends with a 5, I'm thinking should divide by 5. Should be able to put a 5 times something here. How many times though? 5 doesn't go into 1, goes into 10 twice, goes into 5 once. Again, I can't use 2 anymore. I now can't use 5 anymore. They're my easiest to divide by, but I probably can divide this by 3, and 3 goes into 21 7 times. And as it happens, 7 is also prime, so I can stop, okay? Now, writing that as a product of prime factors in index form, well, the product of prime factors is just writing all my circled numbers, all my prime numbers as a time sum. Okay, the index form is if there's more than one of the same, we write it with an indice. So for example, there's 2 2s, so we can write 2 squared instead of 2 times 2. Now there aren't more than 1 5, there isn't more than 1 3, and there isn't more than 1 7, so the rest can just follow on there. Okay. Algebra, factorizing nth term and rearranging formulas. Okay. So factorizing. For us in this exam, right, we're going to focus in on factorizing with a single bracket. So the kind of 2-term things like this. What can we take out? What are the highest common factors? What goes into both these things? Start with numbers. So I'm seeing that 12 and 18, they're both in the 2 times table. But if I take a bit of time, are they both in the 3 times table? 3, 6, 9, 12, 15, 8. Yes, they are. Are they both in the 4 times table? Well, 1 is, but 18 isn't. They're actually both in the 6 times table. Are they in the 8s? No. 10s? No. 12s? Well, 12, I'm just thinking out loud. But the highest one I can work on is 6. And I think this one's a bit more obvious that they're both in the 5 times table, and there's nothing higher that will go into 15 or 35. However, I'm just kicking chairs. That's the noise you're going to. We've got a letter we can take out here as well. 12x squared plus 18x. So we could take an x out of both those things. And here, 15a squared minus 35ab. There's an a in both of those. And then we're opening brackets. If there's anything going through this, you're like, oh, I need more practice in this. Either ask me, give me more examples of that, or just put these titles into Corbett Maths and find them there, okay? Now we've got to work out what we'd have to multiply these highest common factors by to get back to where we were. 6 times what makes 12? 2. X times what makes x squared? X. Plus 6 times what makes 18? 3. X times what makes x? Well, I've already got the x when I'm times it, so I don't need the x there as well. And down here, we'd have 3a minus 5 times what makes 35? 7. The difference here is, even though that a and one of those a's has gone outside the bracket, there is still a b there that I didn't take outside the bracket, so it needs to stay where it is. Right, on to the second thing, nth term. I actually added something here, so my apologies. It's not in the list, but I spotted these. They've been added onto late onto your mock, right? So they're not in the list of algebra things, but we just need to do them, okay? The first 3 terms of this sequence, in other words, swap n for 1, work out what the answer is. Then work out the second term, n equals 2, then work out the third term. Be careful though, right? It's not 2 times 1 squared. Sorry, watch how I write it. It's 2 times 1 squared plus 1. You work that bit out first. 1 squared is 1. 2 times 1 is 2. Add 1 is 3. The second term, 2 times 2 squared plus 1. Do that first. 4. 2 times 4 is 8. Add 1 is 9. And then 2 times 3 squared. Work that out first and add 1. 2 times 9 is 18. Add 1 is 19. Okay, make x the subject, leave them where they are. Leave, like we're solving, go, okay, then all I want this side is the x family. Anything else can go the other side. So leave the x family that side and move the plus 4y to be minus 4y. But I don't want to know 3x, like when I'm solving, I want to know x equals. So we got 10 minus 4y, and we're going to take that times 3 and divide by it. Here, make g the subject, leave him alone. Anything else, that's what's going to move. Leave any other families, move them to the other side. So 3x minus 3t, and the 6g can stay where it is. Don't want 60 though. Want g. Got to divide that by that 6 to get rid of it and leave g. So notice I'm leaving the subject the side it starts, and everything else I'm moving over. So if the subject starts on the left, leave it where it is. If the subject starts on the right, leave it where it is. And that leads us into solving. In fact, it's easier than, right? Because what we're doing here is making the letter the subject, but all we've got is the number family. So the plus 7 goes over as a minus 7. 28 take away 7 is 21. And then 21. But unlike changing the subject of the formula, these actually have answers. So that was 7. The opposite of plus 15 is minus 15. What mistake do people make here? They do 15 minus 7, and that it is not. It is 7, and it's the plus 15 becoming minus 15, meaning that this is a negative answer. And have a think. What's the opposite of dividing by 6? It's easy when I say it like that, isn't it? But you'd be surprised how many people won't times the answer by 6, but will divide by 6. And 13 times 6 is 78. And that's your answer there. So it might be nice if I'd written them a little bit more. Written them on their own. So x equals 7, d equals minus 8. And for this last one, x equals 78. Right. I've started making notes of this and the video stopped. I'm on to my third little section here. Again, I hope there wasn't too much of a jump in the video then. Let's hope that this pen, this slate thing that I use decides to work a bit better than it has been. So in transformations, and in particularly enlargement, there are some other transformations, rotation, reflection, translation, okay, but we'll come on to those after the exam. The one we need for this exam, and the sample question kind of gives that away, is enlarge a triangle by scale factor to about 0, 0. About, right? It's a funny word, about, isn't it? But that coordinate there, that 0, 0, is our center of enlargement. Our job here with the scale factor 2 is to draw a shape that is 2 times as big and 2 times, can I add a letter? 2 times as far away 2 times as far away from the centre of enlargement, in this case 0, 0, or twice as far. Now, if the scale factor was 3, I'd be looking to do the shape 3 times as big and 3 times as far away. But ours is 2, so twice as big, twice as far away. Keep remembering that. Keep remembering that. Now, let's start with, where is this point 0, 0? It's here. Sometimes called, may need to know this, the origin. So it might not say use 0, 0. It might say use the origin. The origin, in this case, just meaning center, okay? 0, 0. We're going to pick a point, right? I tend to go for the one nearest, but you can go for anyone. And I'm going to work out how far it is from the origin, from my center of enlargement to that point. Now I could go up and across, but I'm going to choose to go across and up. So 1 step, 2 steps, and then up, 1 step, 2 steps, 3 steps. If I want to go twice as far away, I need to double those. So I need to go not just 2 steps over to the right, I need to go a third and a fourth. And I need to not go up 3, but I need to double that and go 1, 2, 3, and another 3. 1, 4, 5, 6. So my new starting point is there. Now, that is the bottom left corner of my new shape. That's the twice as far away bit taken care of. That's 1 mark. I now need to draw the shape twice as big. So whereas my original shape went across 1 square, I need to double it. Whereas it went up 2, I need to go up 4. I'll finish that off in a second because I'll have to scroll up to do it. Might be a mess when I scroll up, but you get the idea, okay? So we need to go up 4. Can I get it to finish off? Yeah, why not? All right, it's not the best. But we now have a shape which is twice as big and twice as far away. And you would do exactly the same. I love the fact I called it a triangle. I just thought that as well. It's not, it's a rectangle. But other than that, this was a great question. Okay, let's move on to topic 10. Standard form. Change these to numbers, lovely people. Okay, so the first one, 3.9 times 10 is 39. But I've got to times it by 10 5 times. That's just 1. Times 10 again is 390. And so on. And you can see, right? So we've got 3 times 10 is 39. Times 10, second time. Third time. Fourth time. Fifth time. Second number, 4 times 10. 4 times 10 times 10 times 10 times 10. Line them up. Put the 0 under the 0. Put the 0 under the 0. Put the 0. Oh, I say that. My computer's decided it doesn't want to do that. Put the 0 under the 0. Put the 4. That's meant to be under the 9. Okay. Are we adding or taking away? We are adding. So we're going to get 0, 0, 0, 0. 9 add 4 is 13. Carry 1 and add that 1 onto there. You get 43. And then put your answer back into standard form. 4.3 times 10. And how many jumps to get there? 1, 2, 3, 4, 5 to put it there. So that goes there. Okay, exactly the same, but with a takeaway. You try it. Okay, you try it because there's something wrong with this pen, and I'm just worried. We've got limited time left to get good written answers down for you. Okay, so probability trees. So we're looking at finishing tree diagrams and then some combined events. Well, first of all, filling in a probability tree. Okay, so there are 2 events. A teddy, in this case, it's a teddy grabber and a penny drop. And we can see that on the teddy grabber, we can win or lose, and on the penny drop, we can win or lose. But we've done the penny drop twice because we've branched it starting at win and we've branched it starting to lose to show the 4 things that can happen. The 4 things being a win followed by a win, a win followed by a lose, a lose followed by a win, or a lose followed by a lose. Okay, now the first job is to fill in any missing numbers. So if I win the teddy grabber 1 out of 3 times, then I will lose it 2 out of 3 times. So if I play 3 times and 1 of them is a win, 2 out of the 3 are a lose. If I win the penny drop 2 out of 5, so if I play the penny drop 5 times and I'm winning twice, then I'm losing 3 out of 5 times. Then those numbers, the 2 out of the 5 and the 3 out of the 5, need to be copied down here. Now, I am not saying this is exactly what will happen, but potentially these may be decimals. So if there's 0.3 chance of winning, if this was a decimal question, then you would put 0.7 on the lose. So if there's fractions, make the fractions add up to 1 on each branch. If they're decimals, make the decimals add up to 1 on each branch. If it's a mixture, some are decimals, some are fractions, stick with it. Do the fractions as fractions, do the decimals, right? Because you could get a mixture one where these numbers this side are decimals and these numbers this side are fractions. Well, just do it, right? Do it, fill them in. Copy and complete the tree diagram. Well, we've done that. We've done the completing bit. Work out the probability that Harry loses on the teddy gripper. And he also loses on the penny drop. Poor Teddy, he's lost on both. In other words, lose, lose. Now, to do lose, lose, I want you to imagine on a probability tree an imaginary times line. This is our and. The word times is and in probability. So lose and then lose is what we're looking for. So we need to take the lose on the teddy grabber and then he's lost on there. 2 3s are 6 and 3 5s are 15. Okay, now slightly harder. What's the probability that he wins on exactly one machine? So we got to follow. Remember, this is combinations now. We talked about in the list combinations. So the combination here, if he wins and then wins, has he won exactly one machine? No, he's won 2. So forget that. If he wins the teddy grabber and loses the penny drop, he has won one of them. If he loses the teddy grabber but wins the penny drop, then he has won one of them. I'm going to put my pen down a minute. It's gone bad, so I'm just going to talk you through it. But if he loses and then loses, he's lost both. Okay? Let me try a different colour pen, see if that just helps. Get my pen back to life. No, it's completely dead. Oh, it's kind of drawn randomly now in places. If I do that, where am I? Okay, no, so it's talking through the rest, okay? I thought this might happen. My pen is completely died now. So the probability of him winning on exactly one machine, we'd have to work out both. And by that, what I mean is I'm going to give this pen one more turn. No, I'm not. I'm going to try and draw it with my mouse, and it's going to be horrible, okay? So get ready for this. So we've got win, times lose. Oh, it's going to take me forever to do this. Look at how bad this is. That's right. But then we've also got lose times win. I'm unplugging my pen. This is real world problems here. Oh, I might be back. Might have kicked back in. Lose, yeah, we're back. Times win. So we've gone this way and times those, and we've gone this way and times those. Okay, so that this one is 3 over 15. 1 times 3 and 3 times 5, and this one is 2 times 2 and 3 times 5. But because there are 2 ways to get a 1 win, there's that way and that way. I need to add those together, my final answers. That's tricky, that part C. Be prepared for a part A and a part B like that, okay? Part A, filling in the missing numbers. Part B, doing a times along one of those branches. Now, we've got to be a little bit honest here, okay? We are attending a higher tier, which I always say. So, circle theorems is a new topic and one I've decided to ignore because it's a small mark and quite tricky. So I haven't even put a thing there. Now, if you want to go away or you've got a tutor and you want to look at circle theorems, by all means do. We will at some point before the exam in the summer, but for now, don't worry about it. Same with this one, right? Surds is the maths of square roots. But again, we're talking small marks and we're talking big A star grade topics. And for the amount of time we'd have to spend for me to go over that, again, if you know got someone who wants to show you that, that's fine. But I'm looking now for big wins, right? How I can get easy marks and enough to get really nice grades without really pushing us too much. Okay, so how long have I got left? This is the most ridiculously bitty video ever. I've got about 4 minutes left on this section. I don't think there's any need to go much further than what we have, okay? I'm half tempted to stop where I am. I think what I'll do for a minute is I'll even leave this one. And you have permission to not get these right, okay? A probability. So what I'm going to jump to is something that we have done recently to end, okay? So there's about 4 questions there out of the 16, right? So about 20, I would imagine by the time we had them, about 20% of the paper, a little bit less. Oh, look at that, deciamals. That's good, isn't it? That we're just going to, just for a minute, just go, look, we can sacrifice these. Let's work on the stuff that we know. And if we can do the stuff that we know well, can we easily get an A grade? But we certainly got enough to more than secure our C's and B grades and work towards that A grade, okay? Now, we did these in class. This is a quick reminder. To change this into a fraction, we write 254. We take away from it any number that's not recurring. In this case, any number without the dot. So in this case, the 2. So 252, okay? The bottom number of the fraction, if we're changing this into a fraction, you put a 9 for every recurring number. So every number with a dot. And you start with your 9s, 9, 9. And a 0 for every non-recurring number. Okay? Same again. But this time, it's exactly the same. But this time, both these numbers are not recurring. So I would take them both away. Right? So we're left with 2, 2, 9. The other difference with this one, because we've only got one recurring number, I would put 1 9 on the bottom and 2 zeros, right? But the thing that we've done very, very recently is this. Ignore the minus. 7 squared is 49. Can we remember what does that minus mean we have to do to our answer? 7 squared is 49. It's the reciprocal. The negative means flip, reciprocal, right? So what's the reciprocal of 49? It's 1 over 49. Then we talked about, we are really getting close now, we talked about powers and roots. Flower power, roots. In this case, the 3 on the bottom is a cubed root. The cubed root of 27 is 3. Job done. What about a 2 on the bottom? It's a square root. It's a square root of 36. 6. However, I've spotted something here. It's a minus. What do we say we got to do if it's a minus? That's it. Reciprocal. Flip. This is the one most like it though, right? It's a square root, but we got a fraction. So what's the square root of 1? 1. And what's the square root of 9? 3. So the answer is 1 over 3. Oh, but I've just spotted the minus, the flip. But if we flip 1 over 3, it flips to 3 over 1. And 3 divided by 1 is just 3. So the flip of 1 over 3 ends up being just 3. And the last topic, guys, quadratics, again, we did it, right? So there are 2 topics in here we haven't even done, and then there are 2 topics that I'm just saying, look, for a minute, that one and that quadratic one that I just think, just no for a second, okay? On Wednesday afternoon, I might pick up in the class a couple of those AA star ones or anything else that you want from what we've done in this list that you think, I want him to go back